Hello friends, this is the bilge pump video. I have a 3,700 gallon per hour bilge pump here. This is the casing off a 4,700 gallon per hour bilge pump. You'll notice the difference is a 2-inch outlet versus a 1.5-inch outlet. They both run off of essentially the same motor, which I have right here. It's got the same 6-screw pattern, and this thing basically just sits on top like that. I have 5 different ones I've been testing. I've weighed them all. They're all within a couple hundred grams. I've tested the RPM of everything. The 4,700 gallon per hour is 200 grams heavier and spins at about 200 RPM faster, so it should probably give us the best results, but everything kind of fits together. There's some subtle differences in like the distance from here to here, so I've had to make several different cases, but that's this guy right here, which we'll show you in just a second. But first, inside of this, you have a motor. And this is a big, heavy, it's a brushed DC motor. There's a temperature sensor at the back here, and almost all of these have that temperature sensor. So we are working with something that has a bit of a thermal limit. What I'm trying to do is, without drawing more power from it, maybe a little bit, we'll see what we can get away with. I'm trying to get a more efficient impeller design, because right now what we have is this, and the impeller sits, this is the stock impeller, it sits inside like that, and what that means is the water has to come up around here and then a 90 degrees out the side. They do this so that if it's sitting in the bottom of your boat and you just have shallow water, it actually brings water up and around the motor to help cool it. Not a problem for us gold miners. So that's where I've replaced it with this. You stick your motor inside this, for example, like so. And now you've got that little shaft there, and you can go ahead and stick your impeller on that. But what I did before, I just want to demonstrate, I already created an impeller, and this impeller had a lot of restrictions. For example, it had to fit in the same size casing. Whereas now what I can do is I can make an impeller that's significantly different. This looks like it's a straight edge on the side. That's just the outside for 3D printing. The inside is like a nice curve. It's just, I've actually got a really nice piece of engineering software, thanks to my connections in the Calgary oil patch area. I'm basically able to say I want this many watts. It throws out a design, and it actually matches this impeller to a little stator ring that's a specific height and diameter into a volute that goes around. So if I show you, I think this guy right here, I'm gonna pull this apart like that. So that's the base that sits on top of the pump. And this here, you'll notice the inside is this really nice, smooth thing, like it prints vertically like this. So all the 3D printy, like angles have to be on the bottom. And this inside is like the perfect for water flow situation. And your impeller can then sit right inside that and feeds water into the cone. And what I've done, which I think is pretty cool, so this is for testing on the Seaflow 3700. I've already done all of the testing with the stock casing and stock impeller. I've written down all my measurements, and next up is this. But I've got this removable center core here. So that's one of the impellers I want to test, and the inside of this can match up to that impeller. And so if I have an impeller that's a larger diameter, then I need to make it thinner, or it'll start using too much power. Now if I want this, so this will be hopefully for a higher pressure because it's a bigger diameter. And then the impeller here is a slightly smaller diameter, but it's slightly thicker. So through balancing those, I'm hoping that they both use roughly the same amount of watts because of the thermal limit of the motor. And this is what I'm playing around with because the program isn't perfect. But I can have 2 different impellers, the same casing and everything, and I just swap this thing out in order to get that to work. And so I'd probably shake the camera as I set that down. But the inside face of this, when I thread this thing in, you'll notice that the stator section of this, so let me see if I can get this to show, but there's a flat section around here, and this I can vary that stator length based on the impeller that I'm using, and the impeller would fit in just like that. And it sort of spins around in this direction and collects all the water and sprays it out of there. And this is your end result. Of course, I have a little intake screen, so this will thread on after that red ring goes in. A lot of these things, I'm gonna dial this in a little bit and get it nicer and better, and I may have to change up the design of this part here. Right now I've got a little bypass. You'll see there's a little pipe here. So there's actually that's the pipe. I've got like a water cooling bypass system, so it's still like surrounding the thing with water. I'll probably adjust that going forwards, but for now it's good enough that I can set this up in my test rig. I've adjusted the test rig a little bit, like where my pressure sensor is in a different position, so the readings will be different than before, but I've retested everything on the new rig, and I think it's going to be more accurate this way, and I am testing apples to apples with everything. I started this about 6 months ago. I'm about 160 hours into this so far. I've got a long way to go, I'm sure. And I was just sort of working, 3-4 hours a day in my spare time for about 3 months, and then just no time for 3 months. I'm an Australian tax citizen now, so I got to make ends meet, and I just don't have all the time in the world to work on this. So I apologize to anyone who's been like, "Where's the upgraded bilge pump?" But to anyone new here, we're just about ready, and at the end of this video I'll have this available for sale on my website. So here's the new test rig. I'm running directly off of a 50 amp hour lithium iron phosphate battery, and I'm monitoring the voltage on this, so I'm always within a similar voltage range for every single test. The curve on these is nice and flat, so it's easy to do. I've just got it wired in through this switch right now, and this gives me my wattage rating and voltage and everything. Have a pressure gauge right here, and that pressure gauge comes off of this large pipe, and it's just a 90. I'm doing that differently than I did before, but every single new test is done in the exact same way. And then as far as flow, I'm filling up this tub to that line, and I'm actually able to do that pretty precisely. I had a flow meter before, but the flow meter I think had some variations in it that were some slight inaccuracies. So I'm just going to show you sort of how this and this work together for these tests. And looks like we're just about full here, so I'll shut off the water flow. This is a bit of a diffuser, and what happens is I've got this, there's a thread on the outside and a thread on the inside. This guy right here, which for this test is an 11 millimeter nozzle, it's going to thread into the inside here, and that is basically going to allow me to fill the bucket and see how much pressure I get and what my wattage is and everything. What this thing does is there's enough power with some of these that it kind of does that hose wag thing, and it just makes a big mess everywhere. And filling the bucket, it's just such a turbulent mess, it's hard to tell exactly when it gets to the line. So this is basically something for that to spray at. So I just thread this on here, and the tip of that nozzle is far enough away from this diffuser that it's in no way affecting the actual pressure output of this system. It's got a good distance before it hits this, and then it just spreads everything out and keeps this from wagging around. It sort of makes it so there's no thrust to it, and it also makes a much more relaxed flow of water out the bottom for when I'm filling that bucket, so I can get more accurate results. So basically what I do is I fire this thing up, which it's gonna be a little bubble of air here because it's first time. There you go. And with that underwater, it's actually fairly smooth and even. So all I would do is I just get my timer on my phone, and I get the bucket right up close here, and I go 1, 2, 3, start. So the smaller the nozzle, the longer I have to wait. The bigger the nozzle, like it gets to about 7 or 8 seconds and this thing's full. But I think the accuracy here is pretty good because it's just, I mean, whatever percentage I'm off when it gets to the line, so I'm watching it come up to the line, it's nice and steady, and touching the line, 24.57 seconds. Shut her down. Then I go write that down. So we filled the bucket to that level in 24 seconds instead of 30 seconds. So it's definitely improvement. What's really interesting is that the more you restrict the flow, the less wattage you end up using. It's actually a bit of like a curve where it starts, as you start restricting it, you use slightly more power. And then as you restrict down to almost nothing, you use less and less power because it has to move and accelerate less water. But yeah, so if you were running an 11mm jet for your, dredge or whatever, this system's obviously going to be harnessing a lot more of the potential of that motor. And the numbers change as we get to a really big nozzle or a really, really small nozzle. But I'm going to step it up to the largest diameter nozzle that I'm testing with, and we can compare that with the stock Seaflow to the new impeller. The original hose I was using was the 1 1/8" bilge hose, and this is basically full bore 1 1/8" bilge hose, 28mm. So I take my little diffuser off here. We swap out our 11mm jet to our 28mm jet. There's a little lip in there, so it's actually a 28mm diameter. And we'll throw our diffuser back on. Notice that there's no, like, the diffuser is not affecting the flow at all. There's a nice gap there, and I left it open on the side to demonstrate that. So we'll fire this on down. Of course, I need to take my bucket. Refill that. Fire it up. Okay, so at this point, we are at 222 watts. I'll let that settle for a few seconds before I get my reading. That's 18.5 amps. Our pressure is at 0, so it's unmeasurable. I don't start reading pressure until I get down to a little bit more of a restriction. Just have a look at this. It's moving a decent amount of water. And where is my little phone at? Come on, brain. Here it is. So basically, this is all set up and running, and we're gonna see how long it takes to fill. I'm guessing about 8 or 9 seconds. 1, 2, 3. You can see it's coming up a lot quicker here, and on the line. 8.42. Woo! It actually siphons itself back down. You'll see the water start coming down. The bigger the nozzle, the less accurate I would be, because, like as a percentage of 8 seconds, if I'm off by, 0.1 or 0.2, it's a bigger percentage. But I'm basically doing my best to be accurate and just testing through every single nozzle start to finish. I just showed you an 11 and a 28, but I do the whole gamut, swap out the impeller, do the whole gamut again. And once I've done enough of this to sort of get a rough idea, then I can start dialing in like what's working best, what do I want to, try to test and work on, and see if I can dial this right to where it's ready to actually release as a product. So I've got my chart filled in here. Essentially, I have an Excel graph where I can, based on the diameter of that nozzle and the time it takes to fill, I can determine the velocity. 1/2 mass times velocity squared is the kinetic energy. And so I can sort of see what wattage is going in versus what wattage I would get at a jet for a gold dredge. With the larger diameters, I'm just looking at what sort of a volume I'm getting, and so I can tell guys with high bankers whether we're going to get any more or less out of it. That'll all happen inside later, but this is just something I kind of wanted to show. This Seaflow 3,700 gallon per hour, this Seaflow 3,700 gallon per hour. This is their new 13A series. And the reason I went with Seaflow originally is just because I'm from Canada. You could buy them in Canada, you can buy them in Australia, you can buy them in the US, and I kind of figured that they would all be so different that I had to stick with one brand so I could recommend everyone buy that one thing. Not really the case. My favorite right now is this 4,700 I got off eBay here in Australia. Thanks to a local Australian for pointing that one out to me. And this is just interesting to me. They've made a new design. It cost me about twice as much to buy this as it would to buy that. And the reason I was excited about maybe having a look at it is in their literature, it showed what looks like a closed face impeller on the inside of this thing. And I figured, hey, maybe I don't need to even do any of this, and they've come up with some of their own efficiency boost. Unfortunately, that's not true. The only real difference is here, there's 6 screws to bolt this on, whereas here, it's just like these little pressure clips. So, I can get this to separate. There we go. This pulls off, and unfortunately, look at that. It is the exact same impeller as the regular one. Potentially for a boat, like it has like a backflow valve that comes with, and it is like a good, you know, from a like plastic injection molding design perspective, it's a nice one. But for a gold miner, there's just no reason to spend twice as much money on the 13A series. I also did, like, the weight is the same, the RPM is the same, and when I did the test, the results through the nozzles are the same. So I was excited that maybe they had come up with a better impeller, but it's still the same open face design. And I don't think that's bad engineering. I don't think this is something where, you know, they should go and completely change things. This is probably better at dealing with like debris and sticks and the kind of stuff that's going to go through this screen in your boat, and it does its job of moving water out of your boat. The real advantage of what I'm trying to do is going to be for the electric dredge, where I'm sort of trying to harness like the ideal jet size for creating suction in a gold dredge. But that's just an interesting aside. Seaflow 13A does not, in fact, have a closed-faced impeller. My guess is somewhere around that 17 to 18 mil is where we're gonna see our max power for the dredge jet. So even with an 18 mil jet, we're still at, well, I'd say 2.7 or 2.8 PSI. And it's got some kick to it. So that's 219 watts, about 18 amps. That's why I have the diffuser. So we thread the diffuser on, and now it's much more manageable. But yeah, I should do this test and then, I don't know, just spray it out in the garden for a second and see how far it goes. 2.6, 222, and 12.06. Gotta make sure you dry your hands off so your paper stays good. 12.06, 12.06. Yeah, so I'm just gonna spray this off, then I'll refill my water, finish off the test. I might point you in a better direction here. So I've got the power. I'm just gonna blast this. Woo! Anyways, I don't know if that's a good demonstration or not because you have nothing to compare it to. But yeah, seems like a significant improvement over the stock Seaflow 3700. And I still have that 4700 to test, which should give us a few extra RPMs, and I might be pushing the thermal limits of this motor system, but at some point I'm gonna figure out like at which nozzle size am I burning the most wattage, and then just let it run for 20 straight minutes. And if it runs for 20 minutes in this cold water, maybe it will give you trouble in hot water somewhere, but at least I know that it's good to go for here. It's a little chilly outside. I've got the heater on in this room. But this digital temperature sensor is right there, and I've measured with the calipers that it will clear the motor. So it just sits right in above the motor there. And that's where the safety temperature cutoff is on most of these. It's right at the top. So this way I can close things up and we'll be able to get a reading inside the motor. Yeah, I was having some, 289, I guess 295 watts. It was putting out like crazy. It's like really doing well. But I think this is overpowering it as far as 100% duty cycle. But I'm curious, how long can you run it in cold water? Right now the water outside's really cold. It's like 8 or 9 degrees. And this is how we can figure that out. Another thing I really like about this 4,700 gallon per hour motor unit is they've offset the screws from where these wires come out. On the Seaflow, these wires come out directly above this, and so you kind of can't get at it, whereas here, they're just neatly right on each side, which is so nice to work with. As I'm gathering all my data, thought I'd make a comparison between this pump and this Dyson V8 vacuum. Dyson lists something called air watts. So this thing has 115 air watts of suction. The motor is 425 watts. So that works out to 27% suction efficiency. It's kind of similar to what I'm doing here, where I'm inputting a certain wattage, but then based on the ideal jet size, I can calculate out basically how much water is coming out of a specific size of jet at what speed, and that I can determine as jet watts. So the original Seaflow 3700, I was getting 20.8 jet watts. Now the efficiency was 13.5%, so I had to put in a decent amount of power to get just 20 watts spraying out. This 13A model brought that efficiency up to 15%, and when I threw my special impeller into this pump right here, I went from that 13.5 all the way up to 16.5% efficiency through that ideal jet size. Now, what's really interesting is this guy right here. This is the eBay 4,700 gallon power pump. With the whole case, this exact impeller, I'm up to 21.3% efficiency. Problem is, I have to put in 295 watts to get that. So right now, I'm getting 63 jet watts out of this setup, as opposed to 20.8 out of this. So 3 times, which is super impressive. The efficiency is super impressive. But at this point, I don't think I can use this impeller on this pump at almost 300 watts. I think it's going to overheat. That's where this little temperature probe comes in. Right here, I can see it's currently about 16 degrees inside this case. What I'm gonna do is I'm just gonna pick that ideal jet size where I was peaking at about 295 watts. That's a 16 millimeter for this particular impeller. And I'm gonna let it run. And I'm just going to see what the temperature is every 30 seconds or a minute. And as it starts climbing to what I would consider unsafe levels, I'm gonna stop the test because I do wanna do a bunch more tests with this before I fry it. It obviously has its own little safety shut off at some point in here, so I might test up to that point, we'll see. But yeah, to get 63 jet watts out of one of these as opposed to 20, or like my best case scenario with my original thing was 24.8, we're still over double what we were getting before, which is pretty impressive. And I think I'm gonna have to tune this down a little bit, a slightly smaller impeller, so the jet watts will drop. But if I can keep that efficiency up above 20%, then we're definitely doing good things with this whole custom 3D printed volute. But you gotta get these clamps nice and tight because the pressures are getting pretty high. I think I peaked at about 14 PSI on this. And since I don't wanna have to hold this, we'll throw our diffuser on here. As you can see in the side there, toss that in like so. And let's get this thing loaded up. Current temperature, 15.6 degrees. Can confirm it's cool water right now. Fire that up. All right, I'm reading 284 watts. We're running 24.3 amps right now. So these wires will actually get warm at these power levels. We're definitely demanding too much, but we're at 14.3. Better just shut her off here. I'm going to start a timer and then I can take temperature readings at set intervals. All right, so at 0 seconds, we're at 13.9 degrees Celsius. So we're gonna go temperature and time, and we're gonna fire this up. We're gonna start the clock, and yeah, so we're gonna start at 285 watts. So for 285 watts, we are actually almost 5 PSI right here. About 4.8 PSI. And down to 282 watts, that's still 24.3 amps. 24.3 amps. And yeah, 13.9 degrees Celsius still. Let's see what happens when we get to our first minute in. 10 seconds to go. That updates every 10 seconds. We're up to 14.1 degrees Celsius. So our first minute interval, we'll wait for the update, 14.1 degrees Celsius. Okay, so at 1 minute, we're up to 14.1. 3 minutes in, 16.5 degrees. Holding steady at 280 watts, still 24.25 amps roughly. And pressure is still just about 5 psi. So it's not going to burn out immediately, at least. That's a good sign. Coming up on 7 minutes here. So at 7 minutes, we're at 21.3. We are at 284 watts now. So the wattage is slowly increasing. I can feel the heat now. So around this connection where these thinner wires are, it is starting to warm up outside. This switch is my weakest point of the whole system. So what I'd like to do is connect directly and avoid the switch, because if I lift this up and feel inside, I can feel that switch is getting quite warm. So we're just gonna leave everything running here, but we're gonna go straight through. We're at 285 watts now. I'm gonna pull that. I'm gonna pull this. We're gonna go straight back in. Nothing's changed about the test. Oh, hang on a minute. We're now at 322 watts. So the wiring I'm using for this switch at these levels is actually quite a resistive force in the system. That is interesting. Huh. So 22.6, and that was, yeah, 322 watts. So we're at 9 minutes, 50 seconds. We'll get our final reading, and then I'm gonna actually fiddle with this for a minute. So 10 minutes, 37.3, 319 for watts. The wire's warm, but it's been stable. The temperature is still increasing. The increments, like each minute, the temperature increases, has gotten lower and lower. So there will become like a stabilizing point where it doesn't increase anymore. As the temperature differential between the temperature of the water and the motor sort of widens, then the cooling also gets better, and it'll sort of like curve up to where it just levels off. We're still running strong at 20 minutes in, 316 watts, and our temperature is 42.4. We were at 41.0 5 minutes ago at 15 minutes. So we're pretty much leveled out, and as far as I'm concerned, this thing can actually handle over 300 watts. I'm still not going to design for this. You're already getting such a significant improvement over stock. I'd like to just give a little bit more of a safety margin to make sure the guys running high bankers and stuff don't have cycling on and off issues. And various bilge pumps could differ, so I'd rather err on the side of caution. But yeah, this is pretty good. The wiring right at this connection is getting warm, like easy to touch still, but these are 16 gauge wires just on this little XT60 connection I got for testing purposes. It's 14 gauge wire to the actual bilge pump. So this 16 gauge wire is probably actually costing me even more power out of the system. As far as running a system like this, like we're moving up to 26 amps. The hotter your metals get, the higher the resistance will become. I highly recommend, if you're running like an extension cord, this is 12 gauge pure copper. Use 10 gauge pure copper if you can, and if you're getting that copper coated aluminum, try to go down to an 8 gauge. At these power levels, if you have like a 20-foot cable from your battery on the bank to this thing, it really does actually add up to costing you power just with your electrical wiring. I mean, you saw the difference just the switch had with some short wires. So for my future testing, I'm going to continue with this switch just because the convenience of using it, and I'm still comparing apples to apples. But when I get my absolute best impeller out there, I will directly wire from this to the bilge pump, and we'll see what your best case scenario is in terms of like jet watts and how many watts we're burning through at the motor and everything. But yeah, this is going to be a absolute game changer as far as getting more power, because you can't really get a bigger bilge pump than these 4700s. Not that I'm aware of. Like, that's like the biggest size. And here in Australia, that was 100 Australian bucks, which is, you know, pennies in the US. So you can do a lot more than I expected with one of these power plants with what I've printed out here, which is awesome. That concludes our test. I'm a little bit blown away that the temperature is still where it's at. We're at, what, 43.6 degrees. Yes, the water's cold right now. In Australia, it is winter, but even if the water was 10 degrees hotter and then the motor was 10 degrees hotter, like, I'd say we're still within what I assume would be safe operating in that chamber. Make sure your entire bilge pump is submerged in the water for maximum cooling all the way around. And surprising result. I guess I'll get to, you know, working on the impellers and seeing if I can tune up all the individual components and get this thing as good as possible before I make it available for sale. New day, new adventure, everybody. Hopefully I look a little less tired than I did in those last videos. Just been running myself ragged doing this. Let's have a look at the impellers. So I think it was about 18 hours in so far. These are sort of the highlights. This is the largest diameter and the thinnest outlet. That gives me the highest static pressure. So if I just plug the thing, I get up to about 14 PSI with this. This guy is closer to 10 or 11 PSI, and you'll notice it's slightly smaller diameter and slightly thicker. And that seems to be the most efficient ratio when it comes to running a jet for actual suction. Then we get this one, which is thicker still and smaller still. So we're using similar power. If I make it smaller diameter, I get to make it thicker. And you can see the blade starting to, like when you face it, it looks more like propeller at the start before it goes into the radial thing like this. And this was sort of the extreme example where it's really thick and really tall, and it's straight up a propeller from this angle. Now, in testing, I didn't get enough of a performance gain from this to say this is what you should use to just feed your high banker with the largest diameter nozzle. And the reason is this was designed for that high flow, low head, like emptying your boat out stock impeller. So with my design right here, if we kind of look inside of this, the thickness of the stator, so this little ring that goes right up next to where the impeller would sit, like that, it's basically designed to work with this impeller right here. And if I were to change it up to this, I would have to completely change the design so the water starts to come straight down and then goes down at an angle. And so the stator has to come down at an angle into the collection ring. And just like the effort required to completely redesign this for that. My primary purpose right now is to get the dredge suction working better, and I've seen amazing results with this. So just to get this out, I'm going to just ignore feeding a high banker with a high flow thing for now. We're gonna settle in on this impeller as the most efficient one tested, and you're gonna see some very significant improvements on suction with a suction jet. This impeller, regardless of whether you use the 4,700 gallon per hour bilge pump or the 3,700, it works best with a 17 millimeter nozzle. So I've updated the center core here, J17, so it's 17 millimeter jet. And this new core basically is interchangeable with the old core, the 15 millimeter jet that you use with your stock Seaflow 3700. And this should get you the maximum suction out of the new setup. So what I'm gonna do is I'm just going to go over to the tub here, and I want to do the whole setup and just shoot it through a 17 mil jet out into the yard. And I'll do like the stock versus the upgrade and show you the difference, just to give you some sort of a actual visual idea of what we're doing. And then I'm actually gonna get those nozzles set up and a hose. I've had really good success with suction, even with a stock Seaflow, for my subsurface gold dredge where everything's optimized. But let's say you have an existing dredge or you got a sluice box and you just wanna run a hose into your sluice box. do we have enough suction to do that? And like, how much suction do we have? How much lift do we actually get? So I'll do a little, you know, stock versus fully modified, and we'll sort of see what that looks like in the real world. Hopefully that like is helpful. And I know there's a lot of people out there sort of doing their own DIY mishmash projects. So having like the ideal suction nozzle and pump upgrade might actually let you get away with a little more lift and have an electric dredge that is not a subsurface version, which is something I'm going to be working on in the future. But for now, this will be, I don't know, a good step in the right direction. So let me get this set up, and we'll sort of show you everything, and I'll run over the final numbers and show you what the final result looks like. One thing to consider is when I did all my testing, I ran it through this switch, and that was eating some power. I tried this switch right here. Even here, I'm getting about 260 watts if I run it through this switch, and about 285 watts if I just run it straight from battery through the voltage tester. So any electronics that limit your power, like due to their internal resistance, you should try to avoid. You can just plug these in directly underwater, an XT60 connector here with a little bit of dielectric grease. I tested this in freshwater. There's no parasitic loss coming off a 12-volt battery. That's just like, you can, you know, lick this and it's not going to shock you. And in salt water, I had about 3.5 watts parasitic loss, so not that big of a deal. So I would just use this as your on-off switch, or get a pretty robust on-off switch, or it's going to cost you a little bit of power. This is the 4,700 gallon per hour bilge pump through the 17 millimeter jet. And I'm going to do my best to point it the same, and then we'll show you the stock. So here we go. And cool. All right, we'll see if there's any difference with the original pump. Original stock Seaflow 3,700 gallon per hour, same 17 millimeter nozzle, same water level in the tank, same switch. I have to use a switch because it makes a mess otherwise. All right. I'm not even reading pressure on the gauge this time. We're using a lot less power. I'm at 167 watts. Looks pretty obvious to me. So yeah, basically, you'll use more power, you'll run through your battery a bit quicker, but absolute night and day. One thing I should do is what happens if you take that Seaflow and stick my impeller on it. So we just saw 4,700 versus 3,700 stock. Let's look at 3,700 upgraded. For these tests, I am running it through a switch, so the actual jet watts will be very slightly lower than when I just plug it in directly, but for convenience sake, apples to apples for all of these tests. So we're gonna fire this thing up. Clears the water out of the tube. And let's see if I can So basically at the height of the railing, we are not moving a lot of water, but even down here, it's, I mean, you're not gonna be throwing rocks, like big rocks through here very quickly. And if you were able to keep it right close, call that, I don't know, 10 centimeters off the surface, and you have a short sluice, maybe still passable. But once you put this thing subsurface, that's where you really do start seeing a usable suction. 22 jet watts. Okay, so that's all set up. Temperature sensor, got this guy here. All right. So, I don't know, hold on to this and all right, so we're showing about 200 watts with the switch in the loop here. And I guess this is going to be roughly 36 jet watts compared to 22 before. So that's a noticeable upgrade. And then we were pretty much stopped at railing height before. We still couldn't dredge at this height, but a lot more water coming out. So I'm all the way up there. I'd say like a foot or 30, 40 centimeters above the railing to get to that dribble. But if you ran a sluice low to the ground off the stock 4700, 36 jet watts, not too bad. Now I'm going to upgrade to the Seaflow 3700, which gives you 41 jet watts. Not a big step up, but we'll see if there's any visual difference. So I believe this was from about 36 jet watts. This will be about 41.7 jet watts. So probably an additional 20 centimeters. I think I was like here before. So not a significant improvement over the 4700, but for the 3700, it's doing more and it's slightly more efficient. Now I'm just going to do the feel test. Oh yeah, if you were running and your dredge was this high off the surface, that's workable for sure. So next up, we'll get another angle and we're going to take this, the ebay.com.au 4,700 gallon per hour one. It just spins a few more RPM. And we'll put this onto it with the impeller and we'll see what, I think it was 56 jet watts looks like. So one quick difference I just want to show you here. This has these two hoses coming up. This does not. You won't have these hoses. This was just a test I did to make sure that the pressure differential between where this cooling bypass circuit was actually flowing water, and it in fact does. So, but I'm using, like, it doesn't affect the performance at all. But yeah, yours will just look like this one right here. So we have this guy, and we need impeller 03A to go on there. And then we're going to need our clip. I use a pair of pliers like this, and if you just set the clip on a flat surface, pick it up like this, careful not to lose it, then you can slip it on there nice and easy. Next, this impeller insert is, there's a little lip right here, which lines up with this lip here, so that's where I'm trying to get the seal as good as possible. And just thread that on. Thread on your intake screen. And this is for a 1.5-inch outlet hose, which I think makes sense for a 2-inch dredge or potentially a 2.5-inch dredge. I'll test that later, but we'll see how much power this thing puts out. Time to hook it up to there. Hooked up to the eBay 4700 with the 3D printed setup. This should be, I believe it was 56 jet watts. I expect great things. Okay, burning through about 260 watts with the switch in the line. So you'll get slightly better performance than this with a direct connection. There's that intake. Oh yeah, good suction. Honestly, still passable suction up here. You get 100% run at 2-inch dredge with this setup. At least with a short hose. Not too bad. Do a little thumbs up for the thumbnail. Anyways, just see at this height. Oh, there's the nozzle. All right. Yeah, you can 100% run a surface dredge right here with suction, and better suction the lower you go. That's a win, everybody. All right. Well, here I'm running close to 5 psi through that 17 millimeter nozzle, and suction is good. So, not sure how else I can really demonstrate this thing other than to say it works, and I'm very happy with that. So I would say that if you have a typical surface setup, let's say you're running a surface sluice and you want to pump some water into it with this setup and about 260 to 280 watts, you should be fine. Just make sure that you're using good quality wiring. If you have like a bit of an extension cord out to your battery, I'd go with like 10 gauge pure copper, or if you're gonna go copper coated aluminum, go to like an 8 gauge. Anytime you have a switch in the line, it's gonna pull some power away from you. So just like, because we're getting close to that 30 amps level here, so just make sure you do have some decent wiring. I would just use the XT60 plugs, plug them in, unplug them. If you get those things wet, it's not a problem. A little dielectric grease on there if you're gonna be around salt water, and I would say you're good to go. So the file is available, and what I'm gonna do is I'm going to have the base, depending on which bilge pump you happen to have, the base is a very slightly different height. So just to confirm this will work for you, that's one of the big challenges here, is there's so many different bilge pumps out there. I'm gonna put the base and a little test fit impeller up on for free, so you can print that first, confirm it works for you. When your impeller goes on top with the base screwed in, you should have about like, I don't know, a little millimeter or 2 or 3 of clearance, and if it's all together and doesn't rub and everything's good, you can go ahead and buy the file, and I mean, game changer, absolutely. I'm very happy with how this turned out. Coming up is many more fun things, but I'm a little bit busy for a while, so we'll see when I check in next. But just know that I appreciate your support to anyone who is going to purchase one of these. If you just recently purchased the suction nozzle with a 15 millimeter jet, I'm going to include that core 17 millimeter jet for you. And if you did purchase the impeller file that I had up previously, or a physical impeller from me, you're one of the first people to show your support for this whole project. So reach out by email and we'll see if I can hook you up with the new system. I'm not going to do this going forwards, you know, but just because I don't have very many customers right now, it's something I'm able to do, and I want to treat you guys right. So appreciate everyone's support. I hope this helps a lot of people out, and if it does, share it with a friend, let everyone know about it, and help me justify all of the hours that I've put into this project. See you out there in the field, everybody. Cheers. Thank you for watching. One final thing to add. I'm going to include 3 impellers with this file. This is the standard impeller. It's going to be like in the main download, and it is impeller 03A. I made a low power version of this, impeller 03LP, and that is basically going to be just a very slightly smaller diameter in case you want to get a little bit less wattage through your system. However, I've tested this at a 45-minute runtime on a fully charged battery, and we're not getting into any dangerous temperatures, so you should be safe to go. The other impeller I'm including is this 04HF, that's high flow. I didn't get a huge improvement over stock, but if you are looking to feed a high banker instead of one of these dredge jets, that will give you slightly better performance feeding your high banker. All of these impellers through the Utmost Adventurer spray bar can actually provide enough water for that high banker to run. So you can use this to run a high banker. And I have included this little intake screen here. It's got a bunch of intake around the outside and to there. This basically threads right onto there. And I always wrap my pumps with window screen just to keep small debris out. So I figured I'd make a 3D printed version of that. So basically your impeller goes in here. This impeller insert will fit all 3 of these impellers. I specifically designed these shrouds to fit them all. Any of these that you want to glue together, you're going to use CA, or cyanoacrylate superglue. The section around here, when you glue this to this, I highly recommend you use a thick superglue or a gel. Put it on liberally and let it properly dry. There is a lot of pressure you can generate in this. I have had this blow itself apart when I printed a model with 15% infill and 2 walls. It just snapped this apart because this whole area was under up to 14 psi and just blew open. So you're going to print this with 100% infill, use a high quality setting. Anytime there's threads, you want to go with a thinner layer line. I use 0.12 millimeters for the layer line on all the threads to get that to work really well. This is designed to be a solid chunk of plastic, no infill. You can use some infill on this, but I have, actually no, you can't. This is also designed to be solid plastic. So I've basically designed it so that there's no just like big areas that would use up plastic like that. This would thread onto here, regardless of which of the 3 impellers you choose. And with this threaded on, it's a nice velocity stack, lines into there. And if I just tighten this all the way in, if your threads are a little bit tight when you first just like screw it together, unscrew it a few times, and they'll loosen right up. Although those Bamboo Lab printers, like, I'm blown away with the quality of this thing. So water comes in here nice and smooth, goes down into there, and this means you no longer need window screen, and it should just thread beautifully right on like that. This outlet, I give you a few options. So you get a 2-inch outlet, 1.5 inches, and the 1 1/8 inches. So whatever build shows you're using, you can plug onto this thing. And there's also an option of this. This gets glued on permanently, but you'll see an option here that has the NPT threads. So if you have a cam lock fitting, you can thread the cam lock fitting onto this, but you need to use the specific version of the threads for that. So you can print it all out. I'm using PETG HF from Bamboo Labs. It's, I don't know, strong enough, but obviously not invincible. It would cost a little more to print this out of a carbon fiber nylon. Depending on what kind of printer you have, you can do whatever you want. But yeah, infinite right to repair. If you break something, you just reprint it. And I mean, I'm blown away. It's an absolute game changer. And I'll put a link to this pump in the description of the video. No affiliate to me. It's just a guy here in Australia said I should give this one a shot. It was about 100 Australian dollars. And if I didn't have a pump, I'd go with this. If I had a Seaflow 3700, then I just go with what I have and you are good to go. So yeah, thanks for your attention. Thanks for watching, and I hope that you go find some good gold with this. Cheers, guys.